Part D, E, and hopefully F. Hopefully I can get the F in this time. I want to make sure that I keep my, obviously my screencast to a reasonable time. So let's take a look at this. This is calculate the number of moles of precipitate that is produced in the experiment. So the first thing I'm going to do is I'm going to take a look at the information that I have. The information that I have looks like that I have here 1.698 is my amount that I'm going to start with, because that is the amount of the filter paper and the precipitate. And then I'm going to subtract the amount of just the filter paper, which is 1.462. And I subtract the two, and when I subtract the two, I get 0.236 grams, and that is just the precipitate, and the precipitate is PbI2. And we discovered that in the net ionic equation last time. So calculate the mass, oh, I'm not there yet. So calculate the number of moles. So that means I'm going to start off with, down here for letter D, I'm going to start off with 0.236 grams of PbI2 all over 1 times, and then 1 mole of PbI2. Okay, so 1 mole of PbI2. Now I'm going to show you, make sure that we are like good doing this so you guys understand. I want to make sure that we leave no stone unturned. Lead has an atomic mass of 207.2 grams. I had to look that up. I don't know that just off the top of my head. But I did know iodine. Iodine is 126.9. So we're going to multiply those, these two here to get 253.8, and I'm going to add that to the 207.2. And when I add those two together, I get 461.0 grams, and that's PbI. That's where I get the 461 from, okay, 0.0 grams. Okay, so what I get from that when I divide the two is I get 0.000. I get 3 zeros, 512, and that's the number of moles of PbI2. Okay, good. So that's the first part. Next part says calculate the mass percent in the iodine tablet. Okay, well, first of all, if I want, that's the number of moles, so if I want to find out how much of the iodine is in for Ki, notice that I have 5.12 times 10 to the negative fourth number of moles. That's the same thing, just in scientific notation. That's for PbI2. And what I do then is I change that, excuse me, because I have 2 moles of iodine I minus for every 1 mole of PbI2. Okay? So that means what I have then is 1.02 times 10 to the negative third. That's the number of moles of iodide. Excellent. Okay, so that, so far we're in good shape. We're not finished with the actual conversion yet. We're not finished doing the math, but at least that gets me to the number of moles of just iodide. So I start off again like this, times 10 to the negative third. That's moles of iodide, and what I'm looking for, though, are the grams of iodide, because I actually have the mass of the tablet. So that's where I'm going to. So 1 mole of iodide is the same as 126.9 grams of iodide, like that. So when I multiply those two, I get just under, or just over 0.1 grams of iodide, like this. Now that's good, because up here at the top, let me shift back up to the top. Come on, give me a, there we go. So now I'm looking at this right here. So the mass of the Ki tablet, of the 0.425 grams of that tablet, only 0.13 is actually iodide. 0.453 grams, I forget. 425. Okay, I'm glad I checked. 0.425 grams, okay? And that's of the tablet. So what that equals then is about 0.306. That's the difference between the iodide and the whole tablet, which means that we're at about 30.6% iodide of that tablet. Okay, good. So the question is for letter F then. We're just about finished. So that was letter E. It says another trial student dissolves a tablet 55 milliliters of water instead of 50 milliliters of water. Okay, so the question is, like, predict whether experimentally determined mass of iodide will be greater than, less than, or equal to the amount calculated in part E and justify your answer. Okay, so where did we completely start from the very beginning in letter D? This is important. It's important not just where what we got for E, but it's important to know where we started from. Now here's where we started from. We started from this value right here, which is the number of grams, and it is the third time that we used a desiccator or whatever we did to dry. Third time drying, okay? So what does drying mean? Drying means getting rid of H2O, because that adds mass that is not part of the precipitate, and the precipitate is PbI2, not H2O. Okay, so that's where we are. So this is going to be a pretty easy question to answer, because if you add 5 milliliters of water to what you've already done, and we're getting rid of the water in our drying right here, then the water doesn't change the mass of, if that's the only thing you're changing, it doesn't change the mass of the iodide that we get out of it, which means it doesn't change the mass, obviously, of the tablet, because you're putting the same kind of tablet into the water, just a little bit more water, but we get rid of the water. So it should be exactly equal to the amount calculated in part E. So there should be no change to the amount of precipitate, because the water is removed. That's why. Okay, so if you're good at listening to somebody's voice and understanding the answer, 5 more milliliters of water that's being removed does not change the mass of the iodide or change the percent. Okay, all right, so it doesn't look like I answered that on here, but if you're listening to it, I did answer it. Water is removed to get the precipitate. So no change. No change. Okay. All right. Hope that helps.